All right, this is where we ended our last video right before we ran out of time. We had just completed the sign chart here in the center. All right, and I pointed out as the time was ending that this is a minimum value, and this one is neither a minimum nor a maximum because it doesn't actually exist at that point. So if we were to take that and put it on a graph, here's what your graph would look like. You can see my relevant points. Here I've got the minimum value, that cube root of 2, remember that we looked at? The asymptote is here at 0, and the x-intercept at -1. No y-intercept because the y-axis turns out to be an asymptote. And you can see that it's increasing on this side. It's decreasing until it gets to the square root of 2, and then it's increasing after that. So that's what your curve sketching would look like. All right, we have one last problem that I want to look at with you. Suppose we have f of x equals x6 minus 7x to the fourth plus 4x to the third minus 2x plus 1, and I am asked to find the global maximum and minimum. Well, I know that maximum and minimums occur at critical numbers, so I'm going to take the derivative of this. It's going to be kind of hard to fit this in here. I'll try to write small. I'm going to move the 6 down in front, subtract 1 from the exponent. 7 times 4, subtract 1 from the exponent. 4 times 3, subtract 1 from the exponent. And then 1 times 2. So I end up with that as my derivative. All right, I'm going to take that derivative and set it equal to 0 so I can find the critical numbers. This is not one that I would want to look at trying to factor. So I went ahead and put it in Desmos, and I have all the critical numbers right here. So the critical numbers, remember, is where your derivative is equal to 0. And I notice now I need to pay attention to my interval, -1 to 3. So look at this critical number. This critical number is not in the interval, so I just don't even pay attention to that one. It's not in the interval that I'm looking at. -0.13312, that one is in the interval. I'll leave that one. 1.916, well, that one's in the interval too, so I'll leave that one. So I have two critical numbers that I'm looking at, and then remember we said in the last video that for global maximum and minimum, you also want to look at the endpoints. You always want to consider the endpoints. So I'm not going to create a sign chart in this case because I don't want to know necessarily where it's increasing or decreasing. I might have multiple local maximums or multiple local minimums. And if I'm trying to find the global one, I just want to know what's the biggest or what's the smallest. So I'm going to take the endpoints, -1 and 3, and I'm going to take the two critical numbers that fall within those endpoints, -0.312 and 1.916, and I'm going to substitute all those back into the original to find the y value that goes with them, because the global maximum minimum is asking about the highest value or the lowest value of the original graph. So I took each one of these and substituted it in on my calculator, and here's what I got. And so now looking at those values, I can see that the smallest number is here. All right, so this is my minimum. And remember, I would say my minimum value is -19.6, and that minimum value occurs at the critical number of 1.916. And then I look for my largest value. Well, I can see that the highest one is here, so that's my maximum. And again, I would say that my maximum value is 265, and it occurs at the endpoint where x equals 3. So remember, the minimum, the maximum value is the y value. The location of that minimum and maximum is the x value. Okay, so now you're ready to begin on your homework. On worksheet 7.5, you can do numbers 1 and 5 at the top, and then we'll have some more video tomorrow and look at the rest of the worksheet from that.